Welcome and thank you for participating in Hawkins Contracting's Materials Refresher Training. This training will refresh you on the fundamentals of 5 courses: aggregates, concrete, asphalt, erosion and sediment control, and plant identification and handling.
Welcome, and thank you for taking part in Hawkins Contracting's Aggregates Training. This training will educate you on what aggregates are, types of aggregates, applications of aggregates, measurements and conversion calculations, and compaction of aggregates. What are aggregates? Construction aggregate is a broad category of coarse to medium grain particulate material used in construction. These include sand, gravel, crushed stone, slag, recycled concrete, and geosynthetic aggregates. Aggregates are the most mined materials in the world. Aggregates are a component of composite materials such as concrete and asphalt concrete. The aggregate serves as reinforcement to add strength to the overall composite material. Due to the relatively high hydraulic conductivity value as compared to most soils, aggregates are widely used in drainage applications such as foundations and French drains, septic drain fields, retaining wall drains, and roadside edge drains. Aggregates are also used as base materials under foundation roads and railroads. In other words, aggregates are used as a stable foundation or road/rail base with predictable uniform properties. For example, they are used to help prevent differential settling under the road or building, or as a low-cost extender that binds with more expensive cement or asphalt to form concrete. Types of aggregate. There are many types of aggregate used for different applications: granular A, B, and O, crusher run, clear stone, and sand. The list goes on, but for this presentation we will focus on the main types we use at Hawkins. Granular A. Granular A gravel is a manufactured mixture of sand and crushed rock 1 inch in diameter and smaller. Granular A contains less than 8% silt to allow for drainage and is intended for use as a granular base under permanent surfaces such as asphalt, concrete, and interlocking stone. It can also be used for backfill. Granular A must be compacted once placed. Granular B. Granular B Type 1. Granular B Type 1, also known as pit run or bank B. It is a blend of sand and stone where stone size varies from pit to pit. Its intended use is as a sub-base material under the base course and can also be used for backfill material. Granular B Type 1 must be compacted once placed and has good drainage characteristics. Granular B Type 2. Granular B Type 2 is also known as 2-inch crusher run limestone. It is 100% crushed limestone from a quarry. It's intended to be used as a sub-base material under the base course. Granular B Type 2 must be compacted once in place, and it does not drain well. Crusher run limestone. 3/4 inch crusher run limestone is 100% crusher limestone from a quarry. It can generally be used when granular A is specified. It's intended for use as a granular base under permanent surfaces such as asphalt, concrete, and interlocking stone. It can also be used for backfill. 3/4 inch crusher run limestone must be compacted once placed, and it does not drain well. 2-inch crusher run limestone is the same as granular B Type 2. Clearstone. Clearstone is a quarried material, usually limestone, that is crushed to particular sizes. The stone consists of 100% fractured stone face to prevent rolling or shifting once in place. All the fines have been removed before shipping, so it has a very good drainage characteristic. Clear stone can be used as a base for hard surfaces, as a backfill material, around weeping tile, for pipe bedding, for French drains, as site entranceways, and as construction pads. Clear stone has a 98% compaction rating without compacting it. High performance bedding, HPB. consists of 3/8 of an inch clear limestone and has great workability. HL6 limestone. This is a mixture of 3/8 of an inch to 3/4 of an inch clear limestone. 3/4 inch clear stone, sizing from 3/8 of an inch to 7/8 clear limestone, generally the most common clear stone used on site. 2-inch clear limestone, sizing from 1 inch to 2 inches of clear limestone, usually needs to be placed by machine. Recycled aggregates. Recycled aggregates is a term used to describe crushed concrete or asphalt from construction debris that is reused in other building projects. The collection of construction refuse is mainly used for road base, cement concrete, or other infrastructure projects. The use of recycled materials for construction is a sustainable move in the construction industry. It prevents materials from having to be collected for building while also preventing more refuse from entering the landfill. This process can be easily done at the demolition site or even a permanent facility. You must be given permission from the soil engineering company before using recycled aggregates for a project. 3/4 inch crushed granular A. 19 millimeter 3/4 inch crushed reclaimed concrete product produced to the same gradation as 19 millimeter 3/4 crusher run or granular A. This product may contain a maximum of 30% recycled asphalt product in it. This product can be used as a substitute for a base material in roads and parking lot. It must be compacted once placed. 2-inch crushed granular A. 50 millimeters 2 inches of crushed reclaimed concrete product produced to the same gradation as 50 millimeter 2-inch crusher run or granular A. This product may contain a maximum of 30% recycled asphalt product in it. This product can be used as a substitute for a sub-base material in roads and parking lots, and it must be compacted once placed. Sand. Sand is a granular material comprised of finely divided mineral and rock particles. It has many uses in landscaping and construction. There are many different types of sand, each to meet the requirements of a specific job. Sand must be compacted once in place. Concrete sand. This aggregate material is crushed and filtered at a quarry and comprised of limestone, granite, or trap rock. It's one of the main ingredients in cement, asphalt, and mortar. You can use concrete sand as a base layer for paver patios or walkways, above ground pools, or as pipe sand. Concrete sand is also mixed with topsoil or mulch and used as top dressing material for lawns and golf courses. Masonry sand. While mason sand is produced in a manner that's similar to concrete sand, the grains of this material are much finer and more uniform. Mason sand and concrete sand can be used for many of the same projects, but due to its fine texture, the mason variety is also an excellent alternative to beach sand. If you're building a volleyball court, playground, or sandbox, use mason sand for a soft feel and attractive appearance. Screen sand. Screen sand is normal sand that has any stones removed. The sand is screened through a 3/8 of an inch screen as to remove any materials larger than 3/8. Pictured here are the three sands: concrete sand, masonry sand, and screen sand. Calculations. Different granular materials have different specific gravities. In order to calculate from cubic meters to tons, you need to know the specific gravity conversion ratio. Use this table to find the multiplier for each type of aggregate. For example, you need 3 cubic meters of washed brick sand. To figure out how many tons you would need to multiply 3 by 2 equaling 6, which means you would need 6 tons of washed brick sand. Compaction. Compaction refers to the increase in soil density due to the expulsion of air using mechanical means. Soil compaction is an important part of the construction process. It is used for support of structural entities such as building foundations, roadways, walkways, and retaining structures. When an area is to be filled or backfilled, the soil or gravel is placed in layers called lifts. The ability of the first fill layers to be properly compacted will depend on the condition of the natural material being covered. If unsuitable material is left in place, it may compress over a period of time under the weight of the earth fill, causing settlement cracks in the fill or in any structure supported by the fill. In order to determine if the natural soil will support the first fill layers, an area can be proof rolled. Proof rolling consists of utilizing a piece of heavy construction equipment, typically heavy compaction equipment, to roll across the area while watching for deflections to be revealed. These areas will be indicated by the development of rutting, pumping, or ground weaving. To ensure adequate soil compaction is achieved, project specifications will indicate the required soil density or degree of compaction that must be achieved. These specifications are generally recommended by a geotechnical engineer in a geotechnical engineering report. Utilize the proper equipment. Choose a machine that applies a vibratory force to the soil. Plate tampers, jumping jacks, smooth drummed rollers, and sheep's foot, pad foot rollers are the main types of compaction equipment. Plate tampers. There are two main types of plate tampers: single direction and reversible direction plate tampers. Single direction plate tampers are generally lighter and easier to maneuver. They shouldn't be used to compact more than 6-inch lifts of soil or granular materials. Reversible direction plate tampers are heavier, so they are harder to maneuver, yet pack better than single direction tampers. They shouldn't be used to compact more than 12-inch lifts of soil or granular materials. Jumping jacks. Usually used for backfill compaction of trenches and backfilling around structures. Best for cohesive material, such as gravels or soils that stick together. These shouldn't be used to compact more than 12-inch lifts of soil or granular materials. Vibratory smooth drum roller. There are a few types of smooth drum rollers: single drum and double drum. Single drum rollers have a smooth drum on front of the machine and 2 tires on the rear of the machine. The drum will vibrate by the push of a button to help compact the material below. Double drum rollers have 2 smooth drum rollers, one on the front and one on the back. These rollers also vibrate by the push of a button and are usually used to compact asphalt, but can be used for granular material as well. Both types of rollers come in various sizes depending on your compaction needs. Sheep's foot, pad foot roller. These rollers are for compacting soils that are cohesive. They have many round or rectangular shaped lugs or feet on the rolling wheel. These rollers are usually used when building up the subgrade material with clay or silty soil materials. Tips for soil compaction. Moisture levels go hand in hand with good compaction. If you are having trouble getting good solid compaction on a cohesive material, such as a gravel or crusher run, adding water to the gravel before packing may help. Be careful not to add too much water, as it will then saturate the gravel and have the opposite effect you are looking for. Compacting in a singular direction will not achieve the same compaction rate as if you compact perpendicular to the direction you started in. Do not compact lifts of more than 12 inches of material. Compaction will be very hard to achieve. In summary, there are many types of aggregates. Refer to project drawings and specs for type of aggregate per stage of construction. Not all materials have the same conversion rates from cubic meters to tons, so please refer to the chart to confirm multiplier. Make sure subgrade, subbase, and base are tested for compaction if required. Try and give soil engineering companies 2 days notice to schedule an appointment. And use the right compaction machine for the right application. Your second topic is concrete. In this presentation, we will review safety standards and expectations, properties of concrete and how to order it correctly, additives, forming, placing, and finishing, common tools, reinforcement, and understanding expansion and contraction. Before you begin, it is important to remember, like any other work we do on our construction sites, that there are many safety precautions we must take before, during, and after we pour concrete. Failure to recognize the dangers presented by the job and equipment could result in fatal consequences. The following safe work practices and safe job procedures at a minimum, should be read and signed off by all workers involved with the work before beginning. Construction laboring, forming and placing concrete, backing vehicles and equipment, and traffic control basics. Dangers. Some common dangers associated with concrete work are as follows: rebar impalement, cuts from exposed rebar ends, crushed by, struck by concrete truck or pump truck, flagman being exposed to traffic, curing compounds, silica dust, causing respiratory problems, caustic burns to eyes and skin, form failure, and blowouts. Properties. Concrete is made up of three basic components: water, aggregate, such as rock, sand, or gravel, and cement. Mixed design. Always refer to the drawings and/or the specifications to understand what type of concrete mix you should be ordering. Remember, on some jobs, you may be required to have a mixed design approved by the engineer. You may also have to call in an inspector to have the concrete tested during the pour. A typical city sidewalk, for example, will likely show a spec of 32 MPa, C-2, 5 to 8% air. What does this mean? This means you're ordering mixed design 2. Bundled in a mixed design, in addition to the MPa, CSA exposure class, and plastic air range percentage, is other important information, including minimum aggregate size, maximum water to cement ratio, and method of placement. All requirements in a mixed design must be met. Whether your concrete is being inspected during the pour or after the fact through order detail confirmations, if any of the mixed design requirements are found not to be met, the result could mean having to break out and replace the poured concrete. Additives. We are able to use different additives in our concrete to be able to give different results: workability, faster or slower cure times, the ability to pour in cold temperatures, and help protect the concrete from cracking through a freeze or thaw cycle. Chemical additives that are used to improve the quality of concrete include air entrainers, water reducers, set retarders, set accelerators, super plasticizers, specialty admixtures, which include corrosion inhibitors, shrinkage control, and coloring. Air entrainment. This additive should be used in any concrete exposed to a freeze-thaw cycle. The chemical additives creates billions of microscopic air bubbles, which allows for the contraction expansion of concrete without cracking. In Ontario, any concrete to remain within 4 foot of final grade should have this additive in the concrete mix. Set retarders and accelerators. These additives can be used to speed up or slow down curing times. This can be most helping when pouring in cold weather to prevent freezing, or in warmer temperatures to prolong the curing time, enabling workers to have more time to finish the concrete before it hardens. Super plasticizers. These types of additives can help to lower the water-cement ratio, creating a higher strength concrete, and to reduce slump when necessary, often helping pours through pump trucks and hydraulic pumps. Tools. Having the right tools for the job is always important. You may think that you are creating a nice looking product, but you may actually be causing harm to the concrete in the future by using the wrong tools. Some common concrete tools needed are magnesium float, a bull float, aka Darby float, steel trowel, wood trowel, aluminum or wood screed, edgers, vibrators, and helicopters. Be sure to read all relevant safe work practices and safe job procedures before commencing work, and wear all PPE as required. The first, most common mistake when pouring concrete is forgetting to wear protective glasses when pouring, as there is often a lot of splashing concrete when working close to the pour. This can cause severe eye damage. The second is not wearing proper attire or gloves, resulting in concrete contacting the skin. This can cause caustic burns and rashes if not removed immediately. It's very important we protect ourselves and fellow workers by having thorough knowledge of the products we use. Forming. When forming sidewalks, place the top of the board to the exact height you want the finished concrete to be. This way you can screed on top of the forms before finishing. Be sure to run string lines, have adequate bracing, and double check all dimensions. When forming walls, build the forms 3 to 6 inches higher than required, allowing you to mark the top of concrete on the forms. This will save time in comparison to trying to set the top of forms to your exact height. When you think you have adequate bracing, brace some more, and then some more. Blowouts due to insufficient bracing are very common. These forms should always be inspected by a competent person before pouring. One more thing, triple check your heights. Pouring concrete. Once all safety devices are implemented, it's time to pour. Carefully fill up the forms you have placed with the specified concrete. With a slab or sidewalk, you are going to want to fill upright to the top of the forms, so that you have enough in place to move on to the first step of the finishing process called screeding. With 2 men in either a wood or aluminum screed, move the screed back and forth along the top of the forms, removing any extra concrete. This will give you a nice flat surface to start with. Using the bull float or derby. Immediately after you have screed the concrete, it's time to get the bull float on the concrete. Work the float back and forth, running perpendicular to the way the screed was used. Keep the float flat to run it over the concrete. You may have to add small amounts of concrete if you notice any low spots. Here's a tip. If the aggregate in the concrete is still exposed, shake the handle of the screed, causing vibration on the float to help push the aggregate down into the concrete. Finishing. Timing is key. Once you have used the float on the concrete, it is time to wait. The concrete will begin to bleed. This means the water will begin to rise to the top. You must wait for this water to evaporate before finishing. If you begin to finish before the concrete has dried enough, the water will be worked into the top layer of cream, causing spalling, dusting, and cracking later on. However, waiting too long may cause you not to get the required finish you desire. Do not use extra water on the concrete during the finishing stages. It's now time to put your final finish on the concrete. Broom finish. This is our most typical finish on a sidewalk. Make sure the broom is clean and free of debris, using water to clean it if necessary. Reach the broom across the forms and pull towards you in a straight line at a consistent speed. Do not stop pulling the broom until it has crossed the entire area. Continue to keep the broom clean for the entire finishing process. Trowel finish. You may be asked to use a trowel finish. Remember that it is not a good idea to use a steel trowel on air-entrained concrete. Use a magnesium float. Wait until all of the bleeding water has evaporated from the top of the concrete and then use the trowel, making an arch shape back and forth until you get the desired finish. This may mean going over the area multiple times. The longer you wait, combined with passing the trowel over the concrete multiple times, will continually make a smoother finish. Mixing concrete. If you are pouring a small amount of concrete and choose to mix bags, do so wearing a respirator, as the dust can be harmful to your body. Add small amounts of water to the contents of the concrete bag in a pail, wheelbarrow, or mixing bucket while mixing thoroughly. Be careful not to add too much water, especially if you have used the last of your concrete. This method can typically be used to pour sonotubes and other small jobs that will eventually not be seen. Reinforcement. Drawings often call for reinforcement in the concrete. This will typically come in the form of rebar or wire mesh. It is important to know the type and size of reinforcement, black or epoxy coated, and the minimum lap of any joints. Sleeve dowels are becoming more popular, and Sika makes a great speed dowel product for easy installation. Have a look at the minimum coverage. This will tell you the minimum measurement of concrete that must cover the rebar. Chairs are available to buy from suppliers to hold the rebar off from the forms to meet your minimum coverage specs. We may need to have the rebar inspected. Call 48 hours in advance to book for rebar inspection and take lots of pictures as well. Cracking. Unfortunately, one of the characteristics of concrete is that it cracks. Sometimes this may not affect the structural integrity of the concrete, however, it always affects its appearance. The cracking is due to the concrete shrinking after it has been placed. A slow curing of the concrete will help it not to crack, however, it cannot be guaranteed not to crack. A few things are done to help the concrete from cracking and to control the cracks. Control cuts. Control joints are placed onto the concrete by cutting approximately 1/3 the depth at which the concrete was poured. These joints do not stop the concrete from cracking, but rather provide a weak spot in the concrete for the crack to happen. This can ensure that the cracks stay straight instead of winding all over the concrete. Expansion joints. Usually, expansion joints are utilized when pouring concrete against any existing structure. The two structures will expand, contract, and move up and down slightly differently. This joint helps keep the two structures separate. Expansion joints are also used in long runs of concrete. This allows for more room for each section to expand and contract. Small sections can expand and contract without cracking. In summary, pouring and finishing concrete takes some experience and expertise to be able to complete to a high standard. Watch while concrete subcontractors pour and finish and take note of their methods and timing. Always be aware of what type of concrete you are pouring and double check on the concrete ticket you receive to make sure that it is in fact the type that you require. Check, double check, and triple check. Concrete is designed to be a permanent solution or application and is not easily removed. Mistakes made during the layout or ordering can be very costly. You will always be more profitable by spending the time to double check and triple check all work than to accidentally make a mistake, causing you to have to remove the concrete and place it again.
Our third course is asphalt. The contents of this presentation include common types of asphalt, safety standards and procedures, how to install, mix designs, and common tools. Common types of asphalt include HL8. This is commonly used as a base coat in a two-coat application. HL3. This mix is designed for a finish on pathways or roads, giving a relatively smooth finish with good durability. The aggregate used is smaller than that of an HL8. And HL3 virgin. This mix is more commonly used on driveways or areas that require a smoother finish. It contains more fines to fill voids to create that smooth finish. Other mix designs exist. Here is a chart of typical mix designs used in Ontario. Take a moment and have a read. Superpave is a method of design mix that specifically takes into consideration the weather that the asphalt will be exposed to and the amount of traffic. Its compaction is done with a gyratory compactor rather than a smooth compactor used in conventional methods. This is uncommon on our workplaces. The following tools are commonly used when installing asphalt: rakes, shovels, gas tamper, hand tamper, roller, spreader, and loader. Maintaining health and safety during asphalt operations takes some work. Identify all asphalt work-related hazards and the required controls for those hazards by reviewing these safe work practices and safe job procedures: asphalt paving by subcontractor, backing vehicles and equipment, construction laboring, handling diesel and gasoline, roller operation, and skid steer operation. After reviewing all relevant safe work practices and safe job procedures, be sure to wear all necessary PPE. Gloves, long-sleeve shirts and pants, high visibility clothing, safety footwear, and a hard hat are all required when performing this work. Try not to stand in one place on top of the asphalt, or it will heat up the rubber soles of your boots to the point of melting. Using plywood under your boots will save you from having to buy a new pair. To prevent asphalt from sticking to tools, it is common practice to apply a coat of diesel fuel to them. This should be done wearing proper PPE and in a contained space so to not impact the environment. You may have to clean your tools and reapply after working with them for a while as the diesel does wear off. Keep the asphalt hot. The most important thing to remember while asphalting is to keep the asphalt as hot as possible until you have placed and compacted it. Use insulated tarps over top of the asphalt when transporting small amounts to keep in the heat. When placing, do not spread the material thinly in layers. Put lots down and then rake it down to your desired thickness. Common city standards do not allow paving under 7 degrees Celsius. This work begins with the base. Be sure to follow all specifications when installing the base for the asphalt. Do not allow moisture in or allow it to freeze. And take extra precautions to keep the base protected, as this will greatly affect the outcome of the asphalt. Compaction is also key. For a 2-inch lift of asphalt, a small gas plate tamper can be used for compaction. Any higher of a lift and you may consider using smooth drum roller to ensure the right compaction. This is only the case when working on small repair jobs. On larger asphalt jobs, such as paving trails or driveways, heavier machinery will be used. You will most likely have to have compaction testing done in these situations. Reclaimed asphalt pavement, known as RAP, is asphalt pavement that has been removed, reprocessed, and combined with virgin material to create hot mix asphalt. RAP saves money, reduces waste, and performs as well as HMA made with all new materials, making it a valuable choice for road construction. Some specifications do not allow the use of RAP in the asphalt, so read all specs carefully. In summary, asphalt work is completed to specifications that must be met. Asphalt work is usually performed by subcontractors that require oversight. This work involves a diverse set of tools, materials, and hazards that makes for many risks that require controls. And understanding the technical aspects and the risks of this product is important to being successful in working with asphalt.
The fourth topic we will be covering is erosion and sediment control. The main contents we'll be discussing are the guiding principles for construction, key definitions, erosion control basics, sediment control basics, legal issues, and OPSD reviews. Guiding principle. Urban development has large-scale impacts to the natural environment and in particular aquatic resources and their natural corridors. Changes to the land use can decrease permeability, increase fine sediment inputs, impact water quality, and increase runoff. These changes create an imbalance in the natural processes and lead to increased flood events, reduced base flows, decreased habitat diversity, and channel erosion. Sedimentation from construction activities is a major contributor to these problems. It is everyone's responsibility to prevent construction-related sediment from impacting aquatic resources and other natural features. Erosion. Soil erosion occurs naturally as a result of the dispersive action of rain and the power of water and wind to initiate soil detachment and transport soil particles across the surface. The extent of erosion depends on climate, topography, and the ability of soils to resist detachment and infiltrate water. Wind erosion. Wind erosion can occur in any area where the soil is not compacted or is finely grained, such as silt. Three main ways that wind can move soil are saltation, creep, or suspension. Saltation is the primary means of soil movement, and it consists of wind moving fine particles across land, causing damage to soil surfaces. Creep or rolling occurs when large-sized soil particles that are too heavy to be suspended by the wind roll over an area and come in contact with particles undergoing saltation. Suspension occurs when the wind takes very fine particles of soil and moves them over long distances. Water erosion. Water erosion is the result of water coming into contact with soil and moving it to a different location. A description of some of the main types of water-based erosion are provided in the next few slides. Raindrop erosion occurs when soil is loosened and detached by the impact of raindrops. This is dependent on the amount, intensity, duration, and frequency of a rainfall event. Surface runoff is the process where water during rainfall events accumulates along the surface and travels toward the watercourse. When water travels down the face of an exposed slope in concentrated paths, deep furrows or rills can form. When this concentration is severe enough, multiple rills can combine and form into a larger gully that looks like a V-shaped depression. Bank erosion is the wearing away of any stream or river bank due to fluvial erosion, which is the direct removal of soil particles by flowing water, or mass failure, when the weight of the bank exceeds the strength of the soil, causing the bank to collapse. Shore erosion is caused by the striking action of strong waves within lakes and seas against unprotected shorelines. Vigorous waves can be accelerated by strong winds, causing further damage to shorelines. Pictured here are some examples of bank and land erosion. Pictured here are some of the solutions that can be used to ensure erosion control. Sedimentation. Sedimentation occurs when eroded material that is being transported by water is separated from the liquid flow and settled against a barrier, for example, the bottom of the body of water. Some of the main factors that need to be considered when dealing with sediment control are surface vegetation and buffer zones, slope angles, soil types, and distance to aquatic habitats. Sediment control impacts. The discharge of high sediment loads to natural watercourses has major effects on receiving waters and aquatic habitats. Some specific examples include degradation of water quality, damage or destruction of fish habitat, increased flooding, elevated levels of in-stream erosion influencing the geomorphic stability or instability of the watercourse channel, and reduced navigation in waterways. Some effective sediment control measures include silt fencing, straw bales, storm inlet traps, sediment ponds, rock check dams, and intercepting berm. Legal authority needs to be considered when dealing with erosion and sediment control. The three governing bodies include federal, provincial, and municipal. Federal, with the Federal Fisheries Act, is one example. Provincial has Ontario Water Resources Act, and municipal includes Conservation Authorities Act. Every control device or plan has specifications that need to be followed. Be sure to follow all engineer drawings and specs to ensure design effectiveness. In summary, changes to the land use can decrease permeability, increase fine sediment inputs, impact water quality, and increase runoff. Erosion occurs naturally by wind, water, or other natural agents. The separation of particles settling to the bottom of a body of water is called sedimentation. Erosion and sedimentation control are regulated by three governing bodies: federal, provincial, and municipal. Our last and final topic is plant identification and handling. In this refresher training, we will talk about plant keys, hazardous species identification, general plant handling, and tree planting guidelines. Plant identification is the process of matching a specimen plant to a known taxon. It uses various methods, most commonly dichotomous keys or multi-axis keys. Dichotomous keys. A dichotomous key is a tool that allows the user to determine the identity of items in the natural world, such as trees, wildflowers, mammals, reptiles, rocks, and fish. Keys consist of a series of choices that lead the user to the correct name of a given item. Dichotomous means divided into two parts. Let's practice identification using the dichotomous key tool by focusing on trees and shrubs. Is it a woody or non-woody plant? A tree or a shrub is a plant that contains woody materials in its stems. The stem can live through the winter and continue growing in the following year. They can be full-size trees, small trees, shrubs, vines, or small plants only a few inches tall, referred to as subshrubs. Is it a tree or a shrub? A shrub is usually defined loosely as a small tree, usually with more than one main stem or trunk. It includes woody plants down to the smallest possible, even only a few inches tall. These are known as subshrubs. Woody vines are also usually considered to be shrubs. The size criteria refers to the normal mature size of the plant. Thus, a young sugar maple is not a shrub. A tree is what we commonly think of as a tree, tall and usually with a single trunk. Is it a conifer or a deciduous tree? Conifers are trees and shrubs with needles: pine, spruce, fir, cedar, juniper, and tamarack. They retain their needles year-round, except for tamarack. Deciduous trees and shrubs are all others. The leaves of deciduous trees and shrubs die every autumn and are usually shed. Some species retain some or all of their dead leaves until the following spring, though. Deciduous. Is it alternate, opposite, or whorled? The terms alternate, opposite, and whorled refer to the arrangement of leaves and twigs. In an opposite-leaved tree or shrub, the leaves and stems are arranged along the stem in pairs. The only opposite-leaved trees in Ontario are maples, ashes, and horse chestnut. In an alternate-leaved tree or shrub, the leaves and stems are arranged along the stems in an alternating fashion. In a plant with whorled leaves, the leaves are arranged the same as for opposite-leaved plants, except that there are usually more than two leaves in a group. In other words, where there would be a pair of leaves, there are instead three or more. Note that plants that have whorled leaves often have quite a few opposite pairs as well. For this reason, species with whorled leaves are included with opposite-leaved species. Does it have compound or simple leaves? Compound leaves are those that are made up of smaller leaflets, usually 5 or more, sometimes as many as 13 to 15 or more. Simple leaves are the usual single leaf. Tree identification key summary. Conifers: pine, spruce, fir, hemlock, lark, tamarack, cedar, juniper. Deciduous: opposite, compound-leaved, ash, horse chestnut, and one species of maple. Opposite, simple-leaved, maple except for the one species. Alternate compounded leaves: walnut, hickory, Kentucky, coffee tree. Alternate simple-leaved, all the rest. The first hazardous plant that we will be discussing is poison ivy. The leaves of poison ivy have 3 pointed leaflets. The middle leaflet has a much longer stalk than the 2 side ones. The leaflet edges can be smoothed or toothed, but are rarely lobed. The leaves vary greatly in size, from 8 to 55 millimeters in length. They are reddish when they appear in the spring, turn green during the summer, and become various shades of yellow, orange, or red in the fall. Poison ivy treatment. Wash any areas of your skin you think may have come in contact with poison ivy with soap and cold water. Cold water should be used because hot water tends to open the pores, increasing the chances of the resin being deeply absorbed into your skin. If soap is not available, vinegar, 2 tablespoons in 1 cup of water, or alcohol, half a cup to half a cup of water, can be used. These practices may not prevent a reaction, but will likely prevent the infection from spreading. If a reaction does develop, see your doctor for treatment. Skin irritation resulting from exposure to poison ivy normally disappears in 7 to 15 days. The next hazardous plant we will be discussing is giant hogweed. Giant hogweed is a federally listed noxious weed. Its sap, in combination with moisture and sunlight, can cause severe skin and eye irritation, painful blistering, permanent scarring, and blindness. Contact between the skin and the sap of this plant occurs either through brushing against the bristles on the stem or breaking the stem or leaves. Giant hogweed. White flowers with 50 to 150 flower rays clustered into an umbrella-shaped flower cluster up to 2.5 feet across. Between 7 and 14 feet tall, depending on growth stage and if mowed or cut. Huge leaves, incised and deeply lobed up to 5 feet across. Stems are green with extensive purple splotches and prominent coarse white hairs. Stems are also hollow, rigid, 2 to 4 inches in diameter, and have a thick circle of hairs at the base of the leaf stalk. Seeds are dry, flattened and oval, approximately 3/8 of an inch long, and tan with brown lines, extending 3/4 of the seed length that widen at the ends. Many plants are often misidentified as giant hogweed, the most common plant being cow parsnip. What to do if you come in contact with giant hogweed? Immediately wash the affected area thoroughly with soap and water and keep the area away from sunlight for 48 hours. This plant poses a serious health threat. See your physician if you think you have been burned by giant hogweed. If you think you have giant hogweed on your property, do not touch it, but please call the Invading Species Hotline at 1-800-563-7711. Do not attempt to remove hazardous plants yourself. Contact professionals to do the job. If the plants are to remain or you are waiting for professional removal, block off the areas with hazardous plants to ensure no one makes contact with them. Tree planting guidelines. Minimize stress to your trees. Protect your tree well during transport to avoid bruising the bark and breaking twigs, branches, and buds. Pad the tree trunk and branches with burlap and tie all loose ends with soft rope or twine. Keep the root ball moist and cover exposed bare roots with wet burlap or moss. Cover tree crowns with wet burlap to prevent drying of the tops, especially evergreen. Keep the tree in a shady location until it is time to plant. Prepare the planting spot. Remove grass, weeds, and ground cover within a 50 centimeter radius of the planting hole. These plants compete with the tree for water and nutrients. Dig the hole at least twice as wide as the container or root ball into the depth of the root ball. Roughen the sides and bottoms of the hole to allow root penetration. If good quality soil is not available, break up the turf taken from the top and put it in the hole around the root ball, where it will be able to break down into good rooting soil. Peat or loam, if added, would improve this mixture. Soil in the hole should be moist, not too wet or too dry. A cone-shaped mound of soil at the bottom of the hole is advised for bare root trees. This will allow the roots to develop downward and outward into the surrounding soil. Prepare your trees for root growth. For bare root trees, loosen the roots with a spray of water and straighten them to prevent doubling under, crowding, and crossing. Do not expose the roots to direct sunlight or drying winds for more than a minute to avoid damaging the fine root hairs. For trees in container, trees should be kept in the container until the last possible moment before planting. For trees in burlap, trees wrapped in burlap should not be soaked prior to planting. The burlap should be removed prior to planting rather than leaving it to slowly decompose. Roots circling the outside of the root ball should be clipped, and roots matted on the bottom should be cut off. Plant your tree with care. For bare root trees, the root crown is set on the mound and the roots spread over and down the sides of the mound. Refill the hole with good quality soil, gently raising and lowering the tree while filling to eliminate air pockets. For burlapped and container trees, plant the tree so that the top of the root ball is flush with the top of the hole. Fill the hole in and around the root ball with good quality soil or soil removed from the hole. Tamp the soil around the root ball until the hole is 2/3 full. Fill the remaining space with water to settle the soil and allow the hole to drain. Finish filling the hole with soil and make a ridge of soil around the root ball to direct water towards the roots. Water applied beyond the root ball is not available to the tree until roots grow into the native soil. If soil settles after a few days of watering, additional soil may be required to refill the planting hole. Here is a tree planting detail. Please review this diagram to ensure you are familiar with tree planting guidelines. This is a tree planting detail for trees on slopes. Please review this diagram so that you are more familiar with tree planting guidelines. In summary, plant identification is a difficult and critical element in ensuring planting expectations are followed correctly. Use a plant key for identification when the plant is not labeled. Proper plant handling is an important precursor to plant health, so handle with care. Planting should not be taken lightly. It is critical to the short-term and long-term health of the plant. Beware of hazardous plants. Take appropriate measures to ensure you are not surprised by them.
Congratulations, you've reached the end of this training presentation. Thank you for participating in Hawkins Contracting's Materials Refresher Training. Please complete the test to conclude this course.